All right, we're going to continue our 5.5 notes. We finished off last time with an example 2, and there were parts A, B, C, and D. The answer to part D was -12, if you want to go find that. We're going to just add to those notes right after that. You can just draw a little line. We're going to do number 15C, which is straight out of the book. I've already got it set up here, so you can copy that in your margin. And here we go. So we have to find the area underneath this curve right here, but this curve happens to be an absolute value function. So the tricky part here is knowing how to graph that in the first place. There's a couple ways to go about it. I think one of the easiest ways is to plug in the values on the left and the right, the -1 and the 2, and you can just plug in some values in general. If you just go like, hey, what's -1 and then 0 and then 1 and then 2, and just evaluate by plugging -1 in. So -1 times 2 is -2. -2 minus 3 would be -5, and that turns out to be a 5 because you take the absolute value. 0 goes in and that goes away. You have a -3. Absolute value of that is a 3. 1 goes in. You get 2 minus 3, which is -1, but absolute value is 1. And then 2 goes in. You get 4 minus 3, which is 1 also. There is a special time when the absolute value of 2x minus 3 is equal to 0. That happens when 2x minus 3, the inside, is equal to 0. And if you fast forward, that turns out to be when x equals 3/2. So if I were to sneak in right here 3/2, we would get a 0. So that's our x-intercept. That's important for us. It'll make it easier for us to see what's going on with the graph. All right, so quick little picture here. Let's see, over to 2. So we need to go left 1, right 2, and then we'll go 1, 2, 3, 4, 5. I want to definitely get up to 5 just so I can see that that point -1,5 is reached. Somewhere over there. This is not going to be perfect, but we'll do our best to make it look decent. 1, 2, 3. And then it does have slopes of plus or minus 2. You can see that right here. So it's down 2 over 1, down 2 over 1, so it lands about right there. So 1, 1, which we already knew, it's in the table. 1, 1 is here. And then 2 when it's already bounced and come back up. And then our, so our 3 over 2, that's 1.5. So that's this guy right here. That's 3/2. And then that turns out to be an intercept. All right, so I think we got it. Let me go ahead and just sketch that real quickly. So it is a straight line situation, so use your imagination if you could. Pretend like that crosses right at 3. All right, so we need to cut this off over here. We need to cut this off over here. All right, so to integrate, this absolute value function means find the area underneath from -1 all the way over to 2. So that means we have, it's a long equal sign here. We have, let's see, first triangle. Let's see, this would be a base of 1, 2.5. This is 2.5, also known as 5/2. So that's the base. And then we got a height, which we already know is 5. You can see it from the point in our table. So let's see, the area of that first triangle would be base times height, and then divided by 2, or you could say 1/2. Plus, let's go find the second area over here, make that a little bit bigger. So this, let's see, this was 1, 2.5. This is only 1/2 unit wide, but it is 1 unit tall. So we'll go base times height, and then divided by 2, or times 1/2, kind of like we did over here. So at this point, we're just going to put this all together. So 5 times 5 times 1 is 25 over 4. And then we've got, let's see, 1 times 1 times 1 over 4. That's 26/4, which is 13 over 2, which is great. Or you can call it 6 1/2. I'll take either one. You don't need to go to the mixed fraction. 13/2 is perfect. All right, and there were no negative areas because it was an absolute value function that did not dip below the x-axis. Everything's positive. We're moving forward like we talked about last time. Moving forward, and everything's up and above, so positive areas. All right, hopefully you got what you needed there. If you need to, we could pause it so you can finish copying. We're going to move on to number 17 next. Now, 17 has a piecewise function, and the first piece is an absolute value function as well. And the vertex for that absolute value function, this one's a little easier, is 2, 0. You can think of it like this. There's always that a times the absolute value of x minus h, and then a plus k out there. And the vertex is always hk. Well, there's nothing out here except a plus 0. So 2, 0 is your vertex. And then we're going to have the line y equals x plus 2 whenever x is less than 0. All right, I think we're ready for this one. This one won't take too much work to get it going. Let's go over to 1, 2, 1, 2, 1, 2, 3. I don't know how far we're going to need to go here, but I think I'm going to get rid of this stuff up here so I can draw a little bit more. Go a little bit further up. Okay, so that's 4 units up, that's 2 units up. Here's 2 units out, negative 2 units out. Okay, so when x is greater than or equal to 0, we're going to have this absolute value function, which is got a vertex here, and it goes up and crosses at 2. And you know that because you could plug in 0. 0 minus 2 is negative 2. Absolute value would be 2. So it's going to cross right over there. It would have kept going, but it's not going to because, x has to be greater than or equal to 0 for that piece. So this one goes on to the right forever. Oh, and I just realized something. I'm going to need to go way far over here and clean this up a little bit because I just noticed, let me show you what I'm talking about. I've got a 6 here and a 6 and a negative 4. So I've got to go pretty far out to get more graph going. So I'm going to have to go over to negative 3, negative 4. I didn't really think that through. My bad. We'll finish it just fine. So 1, 2, 3, 4, 5, 6. And what we can do is just plug in the value of 6 to figure out how high that should be. So 6 goes in, 6 minus 2 is 4, so that'll be at a height of 4. So let's just go ahead and take it out there. So that's the point 6 comma 4. That'll be helpful later. Shoop. Oops, pretend like that crossed at 6. All right, next. The other piece, and I'll use a different color for this one, was x plus 2 whenever x was less than 0. Well, that's a slope of 1. It's a slope of 1, and it's coming down from that 2, that intercept of 2. This should cross at negative 2 over here, and then it continues down. Let's go ahead and plug in a negative 4 as well, because, you know, we're going to have a lower limit of negative 4. So negative 4 plus 2 is negative 2. So negative 4 should be down at negative 2. So somewhere down here. That seems about right. So that's negative 4, negative 2. And there we go. All right, I think we have everything we need to answer these questions. So let's start with part A, from negative 2 to 0. That's moving forward. We use some different color here. So we're going to go from negative 2 to 0. So that's this point to this point. So we're just going to move forward like this, which means we just need this area right here. Okay, so the base there is pretty obvious. It's 2 and the height is 2. So that would be base times height divided by 2. Final answer would be 2. All right, nothing too crazy on that one. Next up, part B. We're going to go from negative 2 to 2. So that means we need to go a little bit further than that. So keep going over to 2. So we want this section as well. So negative 2 all the way over to 2. And those triangles are congruent. So really you could just double what you had over there. Or you could say, hey, I've got this big base of 4 and a height of 2. So it would be base 4 times 2 divided by 2. Either way, you're going to get a 4. So pretty easy on that one. Next up, we got from 0 to 6. 0 to 6. Let me switch colors here. So 0 to 6. And I think what I'll do is erase some of this stuff in here. If I can do that. Do it carefully here. Doop. Uh-oh. Lost my axis. Let me throw that back in. Beautiful. All right, I need to go from 0 to 6. So maybe just do a little highlight here. We need that. And then we also need this over here. So we need both of those. Okay. So let's see here. The first one, I think pretty easy to see. We got an area that is base 2, height 2 divided by 2. plus, over here, we got a base of 1, 2, 3, 4, times a height of 4, divided by 2. Work that all out, and you're going to end up with 2 plus 16 over 2, which is 8, and I believe the answer is 10. Yeah, that is 10. So there you go. There's part C. All right, part D, we're going to go from -4 to 6. Now I'd like to be a little slick here. We actually have already calculated all the areas. Okay, so hopefully you've kind of realized we have areas. This area out here was 8. This area right here is 2. This area right here is 2. This area over here, we didn't calculate it yet, but we can. It's a base of 2, a height of 2. 2 times 2 divided by 2 is 2. So that's also a 2. What we need to take into account is we're moving forward, and that is down. When that's down, that's going to be a negative area. So part D, we'll start with this first piece. It'll be a -2 plus the positive 2 here. So -2 first, plus 2, plus another 2, and plus the 8. So we could just cancel those out, and we end up with the 10 as well for that one. All right, that's one way to do it. It's not the only way to do it. We could have recognized some symmetry right here and just canceled those in the picture and then just added those guys. So anyhow, there you go. That is number 17. Next, we are moving on to number 24. So for number 24, they asked us to find this integral of f of x from 3 to -2. Well, my first thought is, if I think about these on an axis, I've got a 3, a -2, and a 1. So -2 is here, a 1's here, and a 3's over there. Really, I want to go from -2 to 1 and 1 to 3. So if I were to go like this, from -2 to 3, that's the full distance, all the way from the lowest to the highest. We should be able to break that up into -2 to 1, stopping at a little rest stop there. And then we can add to that, pick up where we left off from 1 to 3. All right, so I think if we set it up like this, you'll see that these two guys are pretty much the same thing, but there's a switch of sign. We can handle that. So let's go ahead and write down what we know for this guy. We know that is an area of 2 already, and this one over here, that was given as a -6. So as it stands, the integral from -2 to 3, f of x dx, is equal to -4. However, if we would like to switch that around, we can do that. All right, if we switch that around, that means we have to put a negative sign on this, which means over here on the other side, we have the -4 that was there, and you're applying a new negative to it. So we're just reversing the sign of what we had. All right, so there is number 24. Okay, last one for this video will be number 26, it looks like. Okay, so they told us in the directions we're supposed to use Theorem 5.5.4 and appropriate formulas to evaluate the integrals. What they're basically saying is split this up into some simpler integrals. Let me make sure I'm reading this correctly. It's -2 to 2. Very good. So -2 to 2, 1 dx minus, I'll go ahead and pull the constant 3 off and leave just the absolute value of x. Because that way, I've got it way easier. All right, so I know how to graph a 1. That's pretty easy, from -2 to 2. Here's -2 to 2. And here's the function y equals 1. Y equals 1. If I were to just kind of enclose that right there, I can easily find that area. So that would be a base of 4 and a height of 1. So that would be 4 times 1. Minus 3 times, let's see, the absolute value of x. Let's do that one by itself. Here's -2, here's +2. And then the absolute value of x looks like this. And if I were to stop it here and stop it there, we can plug in the value of 2 to see how high we're going. Well, that would be a height of 2. That's 2, 2. This is -2, 2 right there. So these are both at heights of 2, which means you have base times height divided by 2. So each of these areas is going to be base times height divided by 2. Same thing, 2 times 2 divided by 2.